Okay, good morning, all of you. Am I audible?
Yes, sir.
Okay, just wait, I am starting. Okay, so very good morning, all of you. We have discussed in our last classes, this is our temperature measurement transducer, okay? And last, we have to discuss in details, that is a thermistor, to know that. So today we will discuss another temperature transducer, that is the RTD, okay? So what is RTD? Anyone? So today we'll discuss the RTD. That means resistance, temperature detector. Okay, so this is the full form of RTD. That means resistance temperature detector, and it is basically uses for the temperature measurement. Okay, so what is the basic principle? What is the basic principles of this RTD? So I am written here. A RTD basically it has another name. It is also called resistance thermometer. My whiteboard is visible, everyone.
Yes, sir.
Okay. Resistance thermometer. So a RTD is an electronic device electronic device used to determine the temperature by measuring the resistance of an electrical wire, and this wire is referred to as a temperature sensor. Temperature sensor. Okay, so this is the basic principles of the RTD, that means resistance temperature detector. I will repeat once again. So sometimes it is also called the resistance thermometer, and it is an electronic device, and it is used to determine the temperature by measuring the resistance. I am broadly discussing previous more classes, that is the passive transducer. In the passive transducer, we have to measure different electrical fundamentals. That means using the resistance property, capacitance property, inductance property, voltage and current, etc. So here, this RTD, it is a basically temperature measurement by the resistance of electrical wire. So here, one type of wire we have to use is, and this wire it is made different materials, platinum, okay, copper, etc. So this where it is referred to as a temperature sensor. Okay, is it clear? So why we have to use it for the temperature measurement? So particular we have to given result, that means it has high accuracy, high accuracy, and it is a good linear result. Okay. And another one, it is wide temperature range. Okay, so that's why this three cause we have to use broadly RTD. Okay, so these are the basic cause we have to use this in our industrial applications for the temperature measurement. It has high accuracy, good linear results. That means unstable. It is stable result you have to give in. Another one, wide temperature ranges. That means it is uses below of the temperature and higher range of the temperature. So that's why these are the basically advantageous. This is also advantageous over thermistor, thermistor or thermocouple. Okay. So previous class we have to discuss the thermistor. You know that that is the temperature ranges. It is too much short, but here you have to use it in broadly temperature wide temperature ranges in the RTD device. So it is uses near about 600 degree Celsius. So I am giving one example. That is a it is minus 270 degree Celsius to 600 degree Celsius. It is the range of RTD. Okay, so please remember these things also. Uh, Most of the MCQ question, it is given what is the range of the RTD sensors. Is it clear, all of you? So please give response. Okay, we go next. Okay, next. So, principle of operations. Principle of operation. Basically, uh, here we have to changes the resistance. So the variation of resistance of the metal with the variation of the temperature is given as the equations RT, this is equal to R0 into 1 plus T minus T0 plus beta into T minus T0 whole square, and so on up to the maximum level of the temperature. So this is the basically mathematical expressions for the RTD temperature sensors. This is RT is equal to R0 into 1 plus T minus T0 first step. Next step, beta into T into T0 square, etc. So here alpha and beta we have to use this for the constant for the different material. So in this industrial applications, we have to use a three type of metal. So one is nickel, copper, and another one is platinum. So these different types of material, it has different constant value. So alpha and beta we have to consider here for the different material. So where RT and R0 are the resistance value at one is T degree Celsius, that means RT, and T 0 degree Celsius temperature. Okay, and here alpha and beta, whatever you have to use is are the constant depends on the beta. So when you have to use a different material, the constant values it is also changes according to our material. Okay, so now the expression is for high range of temperature. That means increase the temperature. Okay, near about 600 degree Celsius. For small range of temperature, the expression can be written as that is RT is equal to R0 into 1 plus T minus T0. So this is the basically small change in device. That means where the temperature changes just a small range. Okay, that means I am giving you one example, that is 40 degrees Celsius to 80 degrees Celsius. So these are the basically small ranges. So in that case, you have to use this equation, that is RT is equal to R0 into 1 plus T minus T0. And previous one, we have to express for the huge range, that is a high range of temperature when you have to changes. So these equations we have to use it. Okay. So I'm drawing a diagram. So you have to give an idea. So basically, it is for the resistance changes. Another one is the temperature scale. We have to denote this axis. So this is for the RT by R0, and another one, this is the temperature. Here we have to plot a degree Celsius. So 0, then 200, 400, 600, 800. So this is the basically scale of divisions: 200, 400, 600, and 800 degree Celsius, and so on, and so on. And another one, this is the basically resistance changes. So first here it is 1, then 2, 3, 4, 5, 6, 7, and so on. So we have to express here 3 types of material, So these 3 type of material we have to use this for our RTD temperature devices: platinum, copper, and nickel. So platinum, it is a basically costly and than the nickel and copper also. So when you have to use this platinum material, it is more stable result. So it is even just like as a straight line. So this is the platinum card when you have to use a platinum type of material. And this is a copper type of material, and another one nickel. I am drawing here. Okay, so this type of card. So I am written here. So this is the platinum material. This is the copper material, and this is the nickel. Okay, so this is the basically temperature versus resistance curve for the resistance, temperature detector, temperature transducer also. So these three type of material we have to use for RTD, nickel, copper and platinum. So here you can see this platinum material, it gives a stable result. Okay, and then copper, it is basically another one is nickel. So platinum, it is more advantageous than the other types of material. And you know that this platinum, it is very much costly other than gold. Okay, so this is the basically graphical structures of the RTG. So please remember these three materials. Here one MCQ question is important. Okay, which type of material you have to use for the RTD of temperature sensors. So now here this platinum we have to use is, I'm written here, platinum has the temperature range of 650 degrees Celsius. Okay, so you have to use this platinum type of RTD, that is the high temperature to the 650 degrees Celsius. Whereas copper and nickel, it is uses temperature range that is 120 degrees Celsius and 300 degrees Celsius. So copper you have to use up to 120 degrees Celsius, and nickel you have to use 300 degrees Celsius. So please remember these two terms. One of MCQ question it is coming from this part also. Okay. Up to this part it is okay.
Yes, sir.
Okay. Now classification. Sorry. This classification we have to classify it into three categories according to our structure, that is circuit structure. So it is basically classified three categories. First one is two-wire. Two-wire. Two-wire RTD bridge. Number two, three-wire RTD bridge. And number third is four-wire RTD bridge. So this is the classification of the different RTD circuits. So two-wire RTD bridge, three-wire RTD bridge, and four-wire RTD bridge. So these are the basically classifications of the different RTD. So first we have to draw the two-wire RTD bridge. So I'm drawing a diagram. Okay, just like for a this type, this is connected this one. Another point it is connected from here. One voltage source here you have to give in. It is connected. So this is Vs, positive, negative, and another point here the main coil we have to attach. This is for the RTD type of material, either platinum or nickel or copper. We have to use this here. This is connected for this one. So this is the RTD, and we express here also RG, and minus, plus, and here one DVM we have to attach. This is called the digital voltmeter. So this is the basically structure of the two-way RTD type of device or RTD bridge. So here you can see these are the two-way. These two-way we have to connect it for the RTD material. So that's why it is called the two-way RTD type of bridge. So this RTD's value, it is measured using a bridge circuit. This is also bridge circuit pattern. By supplying the constant electric current to the bridge circuit, and it is measuring the voltage drop across the resistor. These are the basically different resistors. The resistor RTD resistance, it can be also calculated. The temperature, it can be also determined through this RTD device also. Okay, so this is the basically figures of the two-way RTD mixer. Next, another one, three-way number 2. Three-way bridge, RTD, sorry, three-way RTD. So I am drawing a diagram. This is same as to the two-way diagram also. First, this one, this one, DVM connection from here. One minute. This is not touched from here. This is the pattern, and here RTD type of resistance material you have to attach. So this two is connected from here, and another one it is connected, this one, and here also connected, here also voltage source. Yes, positive and negative. Okay, so this is called, this is the diagram of the three-way RTD bridge circuit. Okay, so this three-way, first, second, and third, this three-way is connected into the RTD type of material. This is the RG. So this is A, B, and C. This A, B, C, these are the basically different compensation line or different compensation lead, or where it is connected the RTD resistance. Okay, but um, principle of operation, these are the same. So here the RTD value, it is measured by using the bridge circuit also, by supplying the constant electric current the bridge circuit, and it is measuring the resulting voltage drop across these resistors also. Then the RTD resistance, it is also calculated, and this temperature, it can be also determined. The temperature is determined by the converting the RTD resistance. So here one chart, it is also available. Okay, so this resistance of the RTD, it is also particular. So this table you have to follow. This resistance, it is follows the these temperatures. Okay, so this is the basically circuit of the three-way RTD resistor. Another part, four-way. Number third, four-way RTD bridge. Okay, so इसका diagram देखो. This one, another, it is connected from here, also connected from here, and 1 voltmeter we have to connect it here. This is the connecting point or connecting junction to the lead, positive and then negative. This is the voltage source, minus, plus. A, B, then C, then D. Okay, so this is the basically called the four type of RTD bridge circuit. So here 1 voltmeter we have to across these two leads, and this is also connected the RTD device. Another one, it is also connected to the voltage source, that is A and B. It is also connected from here. So in the four-way RTD, it is basically uses for the large range of, that is a huge range, large range of temperature when you have to change this. Okay, so that means continuously it is also changes the temperature. Okay, so this time we have to use this type of four-way RTD devices. And basically we have to use this in our industrial purpose, these three-way RTD type of devices. So when you have to use these three-way RTD circuits, so basically the output we have to calculate it. Okay, I am given the number also. This is the R1, R2, and R3. So we have to express the output, that is V output is equal to source voltage Vs, that is R3 by R3 plus Rg minus Vs by V. So this is the output of the three-way RTD bridge circuits. Okay, so here R1 and R2 also, please remember, here R1 is equal to R2, this value of is also same, and another one, if R3 is equal to Rg, that means this one Rg, you know that this is the RTD resistance. Okay, then the output voltage it is equal to 0. That means the bridge circuit is balanced. So when the value of the R3 resistance R3 it is same as to the RTD temperature for the RTD resistance. So in that case, the circuit it is balanced. Okay, that means it is not changes any decreasing or increasing the temperatures also. Okay, is it clear all of you?
Yes, sir.
Now,
So,
yes.
2 वायर RTD ब्रिज और 3 वायर RTG ब्रिज में क्या डिफरेंस हो जाएगा?
Sorry, और एक बार बोलो, सुनाई नहीं दिया. Hello.
सर 2 वायर RTD ब्रिज और 3 वायर RTD ब्रिज में डिफरेंस क्या हो जाएगा?
देखो इसमें हम लोग यूज कर रहे हैं क्या 3 रेजिस्टेंस. उसमें भी देखो रेजिस्टेंस यूज कर रहे थे. इसको देखो इसमें भी 3 रेजिस्टेंस हम लोग यूज कर रहे थे. दिस इज R1, R2 and R3. So this is the basic difference between the 2 wire and 3 wire. This R3 it is also direct connect to the DVM and to the RTD1 terminal also. But when 3 wire RTD we have to use this resistance R3, it is also another difference connections we have to attach here. So this R3 it is not changeable any DVM voltage, that is a digital voltmeter uses. So this is the basic difference between the 2 wire and 3 wire. And another one, this 3 wire it is basically uses just comparable of the 2 wire increasing temperature ranges also. So this 2 wire we have to use the smallest ranges of temperature changes or smallest time we have to use for the 2 wire temperatures RTD system. But in corresponding of the 3 wire, we have to use a long range of temperature changes in any industrial operation. Okay.
Yes, sir.
Okay. So what is the basic limitation? That means when you have to use this RTD to know that I am given in the previous one advantages. So what is the advantage? Why you have to use this RTD over the thermistor or thermocouple? Okay, na? So thermistor or thermocouple it is obviously uses in our temperature measurement, but in RTD it has different advantages. You know, firstly we have to discuss that it has high accuracy. Okay, number 2, it is low drift. Low drift means that is it is not changes any frequent temperature, it is changes also. That means it is stable result. Okay, low drift. Another, it is a wide temperature range. I am given. So it is uses for the minus 270 degree or 250 degree Celsius to 650 degree up to the 650 degree Celsius you have to use this. That's why it is called the wide temperature range. Another one, it is suitability for precision applications. Precision applications. So where the temperature it is very much important in our industrial oriented. That means certain temperature it is changes. It is basically you have to given the particular signals or any buzzer signals or any siren. So this is the basically suitable for the precision applications device. So another one, limitation. तो आप लोगों को तो पता ही है ना, सब मतलब इंस्ट्रूमेंट में 100% आपको नहीं बोल सकते हैं ये मतलब 100% काम करेगा या 100% एक्यूरेसी. सब इंस्ट्रूमेंट में एक लिमिटेशन रहता है सर. सो इसका लिमिटेशन क्या आप लोगों को पता है? बिकॉज इट इज मेजर्ड अप टू 650 डिग्री सेल्सियस. So when you have to use over the 650 degrees Celsius, this RTD, it is not working. Okay. So more temperature, this RTD it is not using. So when you have to use more temperature, that is above 650 degrees Celsius, you have to use another device. I am telling more. Okay, that is pyrometer. You know, this pyrometer, it ranges up to 1200 to 1300 degree Celsius. So this is the pyrometer. Okay, it is also another one temperature measurement of transducer. It is two types. One is optical type, and another one, it is radiation type. Sorry, RADI, radiation type. So this is the basic limitation of the RTD devices. Okay, so this is the basically sufficient in your syllabus. So I am just recall once again. इसमें ऐसे भी क्वेश्चन मतलब हो जाएगा आ सकता है. What is RTD? Okay, what is the application of the RTD transducer of sensors? Okay, what is the basic principle of operations of the RTD device? What is the classification of different RTD device? That is 2-wire, 3-wire, 4-wire RTD device. Okay, ऐसे भी आप लोगों को शॉर्ट नोट में भी आ सकता है. राइट शॉर्ट नोट्स ऑन 3-wire RTD device. तभी आपको ये पिक्चर ड्रॉ करना पड़ेगा, उसका प्रिंसिपल ऑपरेशन लिखना पड़ेगा. What is the advantage? What is the applications? These are the basic things of the RTD temperature sensors. Is it clear, all of you? Okay, so everyone write your own name and roll number in the chat box also. And Rahul is present, regular student Rahul.
Yes, sir.
Rahul, you take a screenshot.
Okay, sir.
Okay. Okay, so if in the temperature sensor, there are the another one, it is also available. So this is the basically thermocouple. So I think all of you read this thermocouple device. Okay, in your physical science, in the whatever you have to read in your higher secondary physics, and also it is also diploma syllabus, that is the physics also, thermocouple. So I am not given the details in thermocouple, so you know that thermocouple. So what is a thermocouple? Please anyone tell me what is thermocouple? No one knows thermocouple. What is the effect of thermocouple? That is the Seebeck effect, Peltier effect. You know, Seebeck effect, Peltier effect. Thermocouple, it is basically one of the temperature measurement device. Okay, you know that it has two junctions. One is the hot junction, another one is the cold junction. So there are two types of material we have to use in these two type of junctions. Okay, so when you have to heat one junction, another portion it is also heated also. So this is effect for the Peltier effect, you know that. So if two wires of the different metals we have to join in together and also heated, it is the one-sided also. The current in that junction, with the two junctions, the kept with different temperature, the current it is changes the EMF, and this EMF you know that it is called the thermoelectric EMF. Okay, so this is the basically different effect. So scientist Peltier, it is first discovered, that name is that is a Peltier effect also. You know that. Okay, so this is a very easy. This is also another one, temperature monitoring sensors or transducers. Okay, so please read in carefully in your room.